Now we'll take everything that we've learned and put it together to solve a system of equations. We're going to do this using the matrix equation that we're going to convert from the system of linear equations. So if you recall the previous matrix algebra where AX equaled B, and we converted that to the matrix equation X equals the inverse of A times B, we're going to use this method by setting up the linear equation into matrix equations first, and then solving the matrix equation to solve the system of equations. So look at sample problem number 2. It says use a matrix equation and a graphing calculator to solve the linear system. Now I know you know a simple graphing calculator method to just solve the system of equations, and that would kind of defeat the purpose here, but that is a great way to check your answer if you're unsure of your final solution. So go ahead and try sample problem 2 by changing it to a matrix equation first and then solving the matrix equation for the solution. We'll start by setting up the matrix equation. Now we'll rewrite this matrix equation as the X equals the inverse of A times B. Now keep in mind the X and the Y stacked together represents our variable matrix. And we'll raise that to the -1 power to show the inverse. Remember, the order of these matrices is extremely important because of matrix multiplication. Your row and column agreement has to work. Then if we punch this into our calculator, you'll get the variable matrix equals to this resulting matrix. Now, here's the final part of this problem. We've solved the matrix equation and gotten a value for each of the variables. According to these matrices, equivalent matrices, the X equals to -7 and then the Y equals to -4. So the X equals to -7, the Y equals to -4. However, since we're solving a system of equations, we know that this X and Y represents a point, and that point represents the solution to our system of equations. Okay, so that's a good example using matrix equations. Now,